So for this part, what we are doing is we are operating with vectors using components. So this lesson will be like, oh, this I know now why we are finding components of a vector. So let's suppose that we have this situation when we have a vector A that is 18 kilometers at 35 degrees south of west. Vector B that is 13 kilometers at 40 degrees west of north. And vector C that is 15 kilometers, and then this is just southeast. When you see something like this, that there is no angle, that means that it's in the middle. That means that the angle between the south axis and the east axis on this case is 45 degrees. This is why we don't even state the angle. Why 45? Because 90 divided by 2 is 45. And what we are doing is we are finding the resultant vector, that is vector A plus B minus C minus D. So in order to do so, I will start by representing those vectors graphically so that we can work on the table and work right away. So for the first one, it's between south and west. So it is in this south, west and south. And it is a vector that has a magnitude of 18 kilometers. And the angle with the west axis is 35 degrees. Now we create the right angle triangle, including the given angle. And then therefore, what we have is two components. The horizontal component, whatever sides goes into the horizontal direction, and the vertical component, whatever side of the right angle triangle goes into the vertical direction. As we see here, the horizontal going west is negative and the vertical going south is negative. And in the relation to the angle, the horizontal is the adjacent and the vertical is the opposite. So now we know that when we are finding the horizontal component, we will use cosine, and when we are finding the vertical component, we'll use sine. If we take a look at the other one, it's west and north. The other vector, west and north. So we'll have a vector that has a magnitude of 13. So this is the magnitude of 13 kilometers. And the angle width of the north axis is 40 degrees. So then we create the right angle triangle that includes the given angle. So the right angle will be, or the width of the north axis. In this way, the sides of the right angle triangle are forming the horizontal and vertical. Whatever is going on the horizontal direction will be the horizontal component, and whatever is going in the vertical direction will be the vertical component. The vertical component is, since it is going north, is negative, positive, and the horizontal component, since it is going west, is negative. And on the other hand, what do we have for the vertical is the adjacent, and what do we have for the horizontal is the opposite in the relation to the angle. The last one is south and east, so south and east. And then what we have is a vector C that has a magnitude of 15 kilometers. and the angle with both axes, east and south, is 45. You can pick whatever you want. Let's create a right angle triangle that includes the given angle. And then as a result of this, we'll have a horizontal component of the vector and the vertical component of the vector. And the horizontal is a positive because it's going east, and the vertical is negative. And in the relation to the angle, the horizontal will be adjacent and the vertical will be opposite. So now we know which ratio we are using. Then, to find the resultant vector, which is nothing but the equivalent vector of all the vectors that you are working with. To find the resultant vector, what we will do is we will build the table. So the table will consist on 3 columns. In the first one, we will sort all the vectors that we are dealing with. On the second one, we will have the horizontal component. And on the third one, we will have the vertical component. So then we are sorting the vectors that we are dealing. A, B, negative C. Oh, we don't have a D. Negative C. And when we are done with the vectors, then we say resultant. So now the horizontal component of a vector A is negative because we state it so. And since we are dealing with adjacent, will be cosine. So 18 times cosine 35 will be 14.7. And when we are dealing with the vertical component, will be again negative because we said so. And since it is going south, and since it is the opposite, will be sine, so will be negative 10.3. When we are talking about the horizontal and vertical component of the vector B, for the horizontal, we will have negative because it is going west. And since we are dealing with the opposite, will be sine. So 13 times sine 40 equals to 8.4. And the vertical component, since it is going north, will be positive. And since it is adjacent, will be cosine. So it will be 9.96. And for vector C, we will have the horizontal component as positive, but the formula dictates us with a negative. So we have a formula here or a relation. So it will be positive. What is that? 15 times sine 45. Sine cosine are the same for 45, so 10.6. And the negative that the formula dictates us, along with the negative that the vertical component tells us to be, will be negative 10.6. Now, in order to find the horizontal and the vertical component of the resultant, what we will do is we will add those components. So in your calculator, negative 14.7 minus 8.4 minus, because positive negative gives you negative 10.6, is equal to negative 33.7. And when we have negative 10.3 plus 9.93, negative and negative will give you positive, so plus 10.6 is equal to positive 10.23. So those two numbers, what are they telling us is that those are the horizontal component of the resultant and the vertical component of the resultant. Graphically, those will be represented like this. A horizontal component, since it is negative, is going along the west. So horizontal component is negative 33.7. And the vertical component, since it is positive, I will just change this. Is 7, and the vertical component, since it is positive, will go up. So the vertical component is positive 10.2. Using those two sides, what we will do is we will create a rectangle, and the diagonal starting from the same point will be the resultant. So now we have two sides of this rectangle are equal 2 by 2 with each other. But when we take a look at this triangle here, in order to find the magnitude of the resultant, by the way, the magnitude, you can write it as this, with a vector with the two lines, or simply r, can be found using a squared plus b squared is equal to c squared. So we'll have negative 33.7 squared plus positive 10.2 squared, and the whole thing is square root negative 33.7 squared plus 10.2 squared, and then you square root the whole thing, is equal to 35.2. So this is the magnitude of the resultant. And now, in order to find the angle, you can use any of the side angles. You can use this angle here, which I'm calling it alpha, or you can use this angle here, which I'm calling it beta. Both of them will be fine. So in order to find angle alpha, then you go inverse tangent of opposite, so that is 10.3, 10.2, okay, 10.2 over adjacent, that is 33.7. So inverse tangent of 10.2 divided by 33.7 will be 16.8. And when you write a statement about the resultant, that will be something like this. The resultant, that is a vector, is 35.2, I believe it is kilometers per hour. Oh no, just kilometers. Okay, 33 kilometers at 16.8 degrees, and this is starting from west going north, so north of west. Or you can say that the resultant is 35.2 kilometers at whatever is 90 minus 16.8, 73.2 degrees west of north. Both of them are correct because in order to find the angle alpha for the first statement, I wrote it as north of west, and for the second one, you would have done through the calculations to find angle beta. Let's take a look now and go over an example that is a bit more complicated. So let's suppose that we have a vector A that is 20 meters per second at 32 degrees south of east. And then you have vector B that is 25 meters per second at west north. And then you have a vector C that is 18 meters per second due north. Oh, due west. Let's make it due west. And what we are looking for is the resultant, that is 2 times A minus 3 times B plus 1 over 4 C. So let's represent those vectors. So we are dealing with south and east for the first one. And the vector will be a vector that looks like this. So vector A with an angle with east axis as 32 degrees. For vector B, we will have between north and west. So vector B is northwest, no angle here stated. That means that you are right in the middle. And you can do whatever angle you prefer. I will do west on this case. And then the third one is a vector C that is due west. The magnitudes are respectively 20, 25, and 18. So now we create a table, and the table consists into 3 columns. The first one is dealing with vectors. The second one is the horizontal components. And the third one is vertical components. You can go vertical, horizontal, doesn't really matter. So when you are finding, the vectors that you are dealing with are 2a, negative 3b, 1 over 4c, and since we are done with the vectors, then we have the resultant vector here. So now let's create a right angle triangle for vector A that includes the given angle. And what we will see here, will have a horizontal component for this vector that is positive because it's going east, and it is the adjacent. And we will have the vertical component of this vector that is negative and is the opposite because it's going south. On the second case, on second vector, we'll create the right angle triangle that includes the given angle. And this will create 2 vectors, the horizontal component of this vector that is negative and it is adjacent. and the vertical component of this vector, which is positive, yeah, and is the opposite. This is a special case, which we have seen on the previous video. So now, the horizontal component of the vector dealing with adjacent means that we will use cosine. So 20 times cosine 32. Again, make sure that the mode of your degree is on, the mode of your calculator is on degree. 2, that the formula is telling you to, times positive 16.96. And then the vertical component will be dealing with sine. Then we will have 2, that the formula is obligating us, negative 10.50, 10.6. And then for B vector, the horizontal component will be 25 times cosine 45, but sine and cosine 45 are the same. So negative 3, that the formula obligates you, times negative, that the position of the vector dictates you, 17.7. And for the vertical component will be the opposite of 45, the opposite, which is sine, but sine and cosine of 45 are the same. So negative 3, that the formula dictates you, and then positive 17.7, that the position of the vector dictates you. And for vector C, we will have the horizontal component is the magnitude of the vector itself. We talked about this case on the previous video. So we have 1/4 that the formula dictates you, times positive 18. Oops, sorry, it's negative 18. Negative 18, because it is going west. Negative 18, and 1/4 times 0, which it is 0. Now, in order to find the horizontal component and the vertical component of the resultant, we will add all those numbers here. So then in your calculator, 2 times 16.96, negative and negative will give you positive, 3 times 17.7, and positive and negative will give you negative 0.25, which is 1/4 times 18. So you will have a value that is positive 82.52. And for the vertical component, you will have negative 2 times 10.6, because positive and negative gives you negative. Minus, by minus, because negative and positive gives you negative. 3 times 17.7 plus 0, which is nothing. So negative 74.3. Those two numbers, what they are giving you are the horizontal and the vertical component of the resultant. And the vertical component of the resultant. Which means that having a positive horizontal component means that you're going toward the east. So positive 82.52. And having a negative vertical component means that you're going toward the south. So negative 74.3. 3. Using those two as a side, we will build a rectangle, and then the diagonal that starts at the same point will be the resultant vector. The magnitude of the resultant will be the square root of 82.52 squared plus 74.3 squared. Notice here that I'm just ignoring the sign because it doesn't really matter when you are squaring up. You always will have a positive one. 74.3 squared, the whole thing square root will be 111 and 1. And the units for this are meters per second, which we are not done because we have to identify the direction. So you can go with this angle, alpha, or you can go with this angle, beta. Both of them will be right. Let's go with beta this case. So beta will be inverse tangent of 74.3 over 82.5. And again, I'm ignoring the sign because I know where the vector is lying. So second function tangent, 74.3 divided by 82.52 will have 41.9 or 42. 42.0 degrees. So then, when you are writing stating what is the resultant will be 111 meters per second at 42 degrees, and this will be going south starting from east. So south of east. Or you can say it is 111 meters per second at whatever is 90 minus 42, 48 degrees east of south. Both of them will be right. You can pick whatever you want, especially if it is a written response. This is the last part of today's lesson.